Assalamu alaikum and a very good evening, ladies and gentlemen. I am Zainab and I would like to welcome you all on behalf of DICE Analytics. It's a great pleasure for me to introduce our speaker today, Mr. Mohammed Zubair, who has been associated with the industry since last 7 years. He is an expert data scientist, people analytics at Jazz, and also leads data science and machine learning trading at DICE. In today's session, you will be exploring on how you can enter into the field of data science, the roadmap to follow, and the shining job opportunities for the aspiring data scientists in the market. To all the attendees, please note your questions during this session and ask your queries in the Q&A session at the end. I hope we all enjoy this session. That's all from my side. Over to you, Mr. Zubair.
Thank you, Zainab, for the introduction. Hello, guys. I'm Mohammed Zubair, and welcome to the webinar, today's webinar. And I hope you all are doing good. We're gonna wait just for 3 to 5 minutes so that all the audience can join us. So till then, I'll ask some random audience for an intro. So let's start with Akib Javed. Hello, Akib.
Hello, sir.
So Akib, if you can introduce yourself, a bit short one, and if you tell me your motivation of joining today's data science webinar.
Sir, I'm from Dabbist. I'm doing masters in data science, and hopefully it will end soon. Uh, in next month, I have a thesis defense. So my motivation is to I worked as a junior software engineer, and I left it, and since 2 years I've
All
been
right.
uh, I've been doing courses and uh, learning how the data science, what is the data science and how it works. So basically, yeah, that's my motivation.
Right. Thank you so much, Akib.
Thank you, sir.
Okay, so in today's webinar, I'm really surprised that we have international audience as well. So I see in chat that Michael from Philippines said hi to everyone. So Michael, if you can a bit introduce yourself and tell us that you're about the motivation of joining today's webinar. Michael, are you there? It's Michael Ortega, if I pronounce it right. Yes, Michael. Michael, we can't hear you. All right, we are not able to hear Michael. So I have selected another international audience. It's his Xuan Ming Liu. So I guess he might be from China. So Xuan, if you can introduce yourself and tell us your motivation of joining today.
Oh, hello. Can you hear me?
Yes, we can hear you, Xuan.
All right. Okay. I'm actually from Singapore, and I'm currently an incoming undergraduate in business analytics. So actually, I've always been quite interested in data science, and I've actually gone through a course in data analytics, and I also would like to basically joining this
Right.
webinar is just for better exposure to what let's say a life in a really a day in the life of a business of a data analyst. Like how will you, let's say, scan through data or visualize through different sorts of data. So actually, it's really interesting to me, and I hope to get a better learning experience, a good learning experience from this webinar. Yep.
Right. Thank you, Zwan.
Thank you.
Thank you. All right, so let's start it. I think we have enough audience over here to start the webinar, and let's discuss what is data science and artificial intelligence. So over here, I'm representing Dice Analytics, which is a Pakistan-based company, and the motivation behind us is that we should create a bit awareness of this new field, which is being roaming around over here. And there's a lot of buzzwords of data science, data analytics, artificial intelligence, machine learning, and deep learning. So over here, we tried to motivate people so that to come in this field and give them knowledge and the required skills so that they can get job in industry. So I am also working as a data scientist. So yes, I share all my use cases and studies that how it's done. So yeah, let's start it. So right now, Dice Analytics is doing a webinar league 2021 in which we are giving 7 free webinars. And right now, this is the 3rd webinar. So we have already done a round of Microsoft Excel, which are gateway to analytics. And then we had another webinar of text mining on 9, which was actually done by Rosario Silipo. She is working at 9. Then after that, we had another webinar related to the data warehouse and BI. And right now you are here to attend my webinar of Data Science Squared and Learn from Experts. And after that, we have some multiple webinars coming up, which is related to big data and DevOps and then deep learning. And in the end, it will be machine learning using no code, and that's a NIME software. So today, welcome you all to the Data Science Squared and webinar. And let's start that what you gonna learn from this webinar today. All right, so first of all, I hope you guys are fan of the Marvel series or maybe the DC comic series. So you might have seen a lot of techy stuff in the movies, and I would like to highlight one of them as Iron Man. So in the Iron Man movie, it is really fascinating to see a lot of artificial intelligence integrated with his armor suit, in which the Jarvis is actually talking to it and making the calls, making the decisions. So the machine was making all of the decisions. So that's why I take the headline over here that the data science, it is the tech that powers the Iron Man. So we have seen in the movies, and the movies picture them in a way that, all right, this is going to be a future. So if you look back at the 1980s, one of the movie was the Back to the Future. So in the Back to the Future movie, they also showed that in 2015 there are going to be a flying cars, and right now in 2020 we have a self-driving car. So yes, the data science is behind it, and oh, what is it? We're gonna discuss it today. So first of all, it's a bit introduction of my about me as well. So I have done education from NUST. It is an Pakistan-based university. So and I have also been graduated from Udacity, where I did some nano degrees related to machine learning and deep learning. Currently, I'm working at JAS Pakistan as expert data scientist in people analytics department. I have also worked in Telenor, Huawei, and yes, I am part of Dice Analytics as well. So you see over here that Tom is making something for the Jerry. He is combining some chemicals over here. So if you refer to this Tom and Jerry cartoon, I, I think that data scientist works just like this. He's using some tools and techniques, many different techniques, because it's a very vast field. So you have to learn many things in it. And the way you see Tom over here, he's making something for the Jerry. So that's how our data scientist really works. So in today's webinar, you're gonna see that what are the tools behind it and how actually the real data scientists work in this field. So let's start with the first buzzword over here. So the first buzzword which I'm going to discuss in today's webinar is actually the artificial intelligence. Right now, we are all the smartphone users and we have access to internet. So somehow we already know that we are interacting with artificial intelligence at every level. We are using Google Maps to get the right fastest route to our destination. Even the security cameras are being used in today's COVID and pandemic situation, where they identify that if someone is wearing mask or not. Even there are thermal cameras from which they are detecting the temperature. Then we are also using some e-commerce websites like Amazon, eBay, and in Pakistan we have Daraz, where we purchase one of the product and they do recommendation of another product with that we can buy. And secondarily, we have some social media in which like Facebook, WhatsApp. Recently, we know that WhatsApp roll out this new privacy in which they said that they're gonna share the data with the Facebook because they want to do a personalized ads for their consumers. So yes, everything is being tried by the artificial intelligence at the backend, and the data is being generated. So we see that it's being applied in most of our industry, and it is also applied in the healthcare. And right now, in the pandemic, it was very much used even by China. We saw in China that how they are leveraging the artificial intelligence by identifying that who can be the COVID patient and how it can be spread. So yes, it is part of our life now, right now. So as it's part of our life, so we need to learn that how we can work on it and what it is technology behind it. So let's start with the scenario over here. So I've designed a scenario that actually what is actually artificial intelligence and how it's already part of our lives since a decade. So let's suppose that there's a customer and he's going to one of the superstore or maybe a retail store, and he's purchasing some stuff, and in that particular he's purchasing Nutella. So many of you guys know that what is Nutella. It is a chocolate spread with hazelnut. So it's very much it is very famous worldwide, and we can see lots of videos on YouTube and Instagram related to it. So yeah, he purchased this Nutella and he went to the shopkeeper. Now in this scenario, let's suppose that this customer is coming to this specific retail store for about last 10 to 15 years. So, and let's assume that the cashier he's interacting with over here is also the same cashier who was hired 10 to 15 years ago. So of course, if you are going to one of the retail stores, the cashier might have known you. Uh, yes, Neara, the recording will be available on our Facebook channel. So yes, if you have something, you can. If you have some urgency, you can leave and you can access the recording as well. So this webinar is actually recorded right now. So I was talking about that if let's suppose that there's a customer who is purchasing Nutella and he's going to the cashier, and the cashier and the customer know each other for about last 10 to 15 years. So based on that, the cashier has a knowledge that the customer is very old and he know him personally, and he comes to this retail store daily. Now, as there are many things which are purchased in the retail store and they are sold as well. So based on that, the cashier know the previous trend that as per the previous trends, we have some other products in the store as well. Nutella is one of them, but there's another chocolate spread which is made by Cadbury, and as per the previous trend, the sales of the Cadbury is not increasing. So the manager or the techie guy behind it, he told that all right, the sales is not good. So he asked the cashier that if you see any of an old customer who is purchasing Nutella, then you can give them offer. You can offer them the Cadbury chocolate spread for some discounted rate. So as this cashier already knew this customer, so as per the knowledge, he knew that this guy is coming here for about 10 to 15 years. So the cashier offered him 50% discount on the Cadbury chocolate spread, and he also told him that you should try it, maybe you will like it, and Nutella costs more, so we are offering you a very limited time offer of 50% off for this Cadbury chocolate. So the idea behind is that the cashier already knew that he's an old customer, so he's not gonna give this offer to the new customer. He's gonna give it to a very old customer who is continuously coming to the retail store where he is working. So let's suppose the customer gets surprised from this offer, and he actually purchased this new chocolate spread on 50% discount. So let's suppose the customer takes it home, and he is enjoying the Cadbury chocolate as well, and comparing it with the Nutella and thinking about that should he purchase Nutella or chocolate spread. Now, let me bring a little bit twist in this scenario. Now, let's suppose that same customer told his another friend that, all right, we have been going to the same store for about 10-15 years, and this particular retail store is offering 50% off on the Cadbury if you purchase the Nutella. So the new customer came over here, who's actually the friend of the previous customer, and he's thinking that, all right, I have purchased Nutella. I'm gonna purchase Nutella, so as I am an old customer as well, so I'm gonna be offered 50% discount on Cadbury as well. But surprisingly, when he went over there, the cashier has been changed. So the previous cashier was working over here, and he found a new job, so he left the retail store, and the new cashier is over here who is looking after it. So over here the new cashier doesn't know this customer because he just joined it, so he's new to the area, he's new to the retail store. So of course he has no previous knowledge that, all right, this particular customer is a very old one and he's coming over here since about 10 years. So he already, the new cashier already know that yes, the sales of the Cadbury are low, but he has no previous knowledge that should he offer the discount to this customer or not, because she's new as well. She doesn't have the previous knowledge. So the customer will say that, all right, my previous friend got the discount, so why you're not giving to me? I'm an old customer as well. So right now the cashier can't make any this type of decision over here. So what she's gonna do, she's gonna say that, all right, I'm gonna ask the manager, and then she will go to the manager. Maybe she will check the previous records. If the customer has made some profile in the retail store, so she will check over there that if he's old customer or not. And yeah, of course the customer is gonna be disappointed. So the catch over here is that whatever decision making is being done in this world, it is based on some historic patterns, some historic trends. So over here, the cashier knew about the history of this particular customer because he already been working over there for about 10 years. So as the human changed, the new human came over here. So the new guy didn't have the previous knowledge. So that's why the decision making is not being done here, over here efficiently. So that's why what is actually AI? AI is actually a task in which the decision making is being done by the machine. So if we replace the scenario with another thing that, all right, the customer is coming to the retail store and he is thinking about that, all right, his friend got the Cadbury as well with Nutella. So if we replace that cashier with a robot, so what the robot is doing over here, that if we replace the robot, the data is already there for this particular customer. So what the robot is gonna do, it's gonna do an intelligent decision over here by itself based on the previous purchases or the previous record patterns of this particular customer. So it's gonna make the decision at the right time that, all right, this customer came over here, he used to purchase Nutella as well. So he's a very old customer. So based on that, we have a low sales of Cadbury. So we should offer this Cadbury at discounted rate to this particular customer. So it's gonna make the decision at the real time. So the discount is being given and the customer will take the Cadbury with him to the home. So the point over here is that the decision making is already been done by us as a humans at every stage of the life. So what the artificial intelligence is helping us, that if there's some problem, if there's some availability problem of human being, or maybe there's some lack of time for the human beings to do any decision making, the machines can help us out in doing the automatically decision making on behalf of us. So that's the whole crux behind the artificial intelligence. Now, you might be thinking that how the machine becomes that much intelligent. So, for about a bit decade, we are already using some of it, and the machines are designed mathematically. So, whatever is decision making is being done at the machine level, all of them is being integrated as a mathematical model at a back end. So if you think about data science, if you think about artificial intelligence, everything behind it is related to mathematics. So all the things are related to it. So let's watch a bit short video in which you will see that how the decision making historically is being done, and from when we have started doing this decision making as a part of artificial intelligence. So although the buzzword is very new for us for about 10 years, but we are doing artificial intelligence for about last decade. So let's watch a short video. Oh, okay. So I think let me share the screen again with the sound. Everyone, are you receiving the sound from my laptop?
Oh, yeah.
Yes.
All right, great. Okay, so we have one of the question which I'd like to address by Khurram. In this view, the financial decision making into investments are also expected to revolutionize by intelligent machine. Yes, of course. So financial decision is being, because there are many, you can say, if I take example from Pakistan, one of the company which is named Grana over here, it is actually doing decision making based on some third party data collected for the particular customer who is coming to their website for the any retail investment or property investment. So yes, based on the income and some consumption of other utilities, the decision making can be done that all right, if this particular customer is potential for any type of investment, so should we approach him that he should invest in this particular area. So yes, financial decisions are being also being impacted by intelligent machines. All right, so let's start the video. I hope you will enjoy this.
Yeah, thank you.
There have been a number of shifts in the way we think about computing over the past few decades.
The terminology artificial intelligence has come in and out of favor in the scientific community. Sometimes it's called machine learning.
We tend to call it machine intelligence these days.
I just call it intelligence.
And sometimes it's just the effort to build machines that are better.
So in the early days, everything was built on logic, doing mathematical integration problems, playing chess. But we realized that what the real challenges were the things that people can do every day.
The real world is actually very messy. Hard logical rules are not the way to solve really interesting real world problems.
You have to have a system that'll learn to get the knowledge in. You can't just program it all in.
Artificial intelligence is an effort to build machines that can learn from their environment, from mistakes, and from people.
And we're still at the stage where we don't know what is the right path and the right breakthrough.
So, I mean, there's certainly a whole raft of different approaches.
One of the subfields we call pattern recognition.
Artificial neural network,
Reinforcement learning, for example.
statistical inference, and probabilistic machine learning.
Supervised learning, unsupervised learning. And we're not quite sure what technique is going to lead to better systems. And in fact, it's probably not one technique for everything. It's probably a bunch of different techniques and combinations of those techniques.
Any progress we make in building truly intelligent systems is going to depend on progress in technology generally. And until recently, we didn't have computers that were fast enough or data sets that were big enough to do that.
And so being able to take a particular problem and spread it out over lots and lots of machines is a very important approach because it makes our research faster.
So there's applications of artificial intelligence around us all the time.
When it begins to work, or it does work, it's all of a sudden given another name.
We're all already using it and very comfortable with it.
Things that now we regard as routine, 30 years ago would have been regarded as amazing examples of artificial intelligence.
Anti-lock braking,
Autopilot systems for planes,
Search,
recommendations.
maps,
To decide whether or not this particular email is spam or not spam.
The ability to translate one language to another with your phone. 10 years ago, if you tried to talk to your computer or to your phone, that would just be hopeless.
We are seeing a steady torrent of these tricks, one after the other, getting figured out right now. And I think a lot of people that are close to the field have this, do have that kind of breathless sense that things are moving quickly.
It's a progressive thing. It's about building things that are slightly better, slightly better, slightly better.
Intelligence is really not going to be something that we ever succeed in defining in a succinct and singular way. It's really this whole constellation of different capabilities that all kind of are beautifully orchestrated and working together.
predicting the long-term future is very difficult. Nobody can really do it. And the bad thing to do is take whatever's working best now and assume the future is going to be like that forever.
All right, guys. So I hope you have enjoyed watching this video in which they give an holistic picture that we are already using artificial intelligence in our daily lives or for about many years. So I would like to highlight one of thing over here that in this video, you'll see this machine over here. So this machine was built way behind about 1950s, which is termed as the first computer. So if I just go through the history over here, so the first computer was actually was built in about 1960s, but there's one of the movie that I have watched, which is Imitation Game, which was released in 2014. So this particular movies was related to the World War II, where the British intelligence wanted to decode the signals sent by the German machines of Enigma. So the Germans were communicating from an encrypted machine, which was called as Enigma, and they were not able to decode it. So this movie is based on the true story where there's one of the mathematician designed a machine to decode the Enigma, the messages from the Enigma. And so technically the first computer was built back in the World War II, but due to secrecy of this information, the British intelligence never told that they made such a machine to decode the Enigma, and that was done back in 1990s when they gave a recognition award to the guy who actually made this machine to decrypt the Enigma messages. So if you got some time, do watch this movie. It's a really fascinating movie where he used some mathematics to decode the Enigma machine. All right, so let's move back to our slide deck. So right now in today's world, so there's a lot of data which is being generated. So normally in our laptops, we have a hard drive of 500 GB, or maybe some of the laptops have 1 terabyte or 2 terabyte, or we can use an external hard drive as well. But if we look at the data being generated by Google, so at Google in one day, the unit used over here is quadrillion. So quadrillion over here, the terabyte is 10 raised to power 9, but the quadrillion is 10 raised to power 24, which is very huge data. But if we combine everything, so right now the global data generated from all of the internet. Everything we are using over here is about 2.5 quintillion. So quintillion is actually 10 raised to power 30. So it's a huge data which is being generated over here, and that's what they told in the video, that in previous years there is not much data, because before internet the data was not generated that much. But since the internet was here, the smartphone devices are here, everyone has access to their computer and laptops, so there's a lot of data is being generated because the user is interacting with the technology on daily basis. So we are already doing some sort of artificial intelligence in our daily life. So based on this data, of course, we need some techniques which are computationally good to make the decisions. So that's why the machine learning is over here. So based on then, what is actually machine learning? So how the machine learning is actually work, that we give it some sort of experience, the experience that human already knew. So we transform that experience into a data. So the data is already there. It's not like that the machine is you don't think like the machine is like a Harry Potter, that it's gonna do some sort of a spell from the wand and it's gonna do the job. Of course the machine will learn from the human, and the human will give the historical data to the machine to learn it. So based on this data, the machine will do the training, and of course the training will be evaluated by the human, that how good the decision making is being done by the machine. And after that, when the training is complete, the necessary future prediction or trends are being extracted using this machine learning. So what type of training, like what type of prediction or task the machine learning do? So the famous task done by the machine learning is called the classification task. In this task, the machine learning is actually trying to learn and predict any type of categorical variable. So in categorical variables, I term that maybe some sort of color, maybe some sort of species, or over here I have told you that maybe it wants to predict that which customer is gonna churn from the retail store or not. So when we talk about a categorical variable, it's actually something like yes or no, or maybe a defined categories, or if you can say that we have an image of cats, so from that catch identify that which of the species is this. So all the species are actually the categories. So any prediction related to a category, this task is termed as classification in the machine learning. Then we have another task, and that task is called regression. Sorry. Okay. So in the regression, we try to predict a continuous variable. So over here, the example of continuous variable I have given is that to predict the sales, it is to predict the demand of the particular item in the next month in the retail store. Because like for example, we have to predict the demand of Nutella chocolate spread in this particular retail store, or we want to predict the price of a specific car vehicle. So so anything related to a continuous value, any prediction related to the continuous value, this particular task is termed as regression in the machine learning. Then we have another task that's called clustering. Clustering is a that particular task in which we segregate or made different groups from a particular data. So actually there are some groups available, and we can do that through the FL's logic, but there are multiple dimensions involved in a particular decision making to form a group from the data. So in this particular task of machine learning, it helps us to segregate a group of data into different groups. So whole data is being divided in a particular based on similar patterns, the groups are being made. Then we have another task, and that's called an association. And this is the same example which I used at the start of the webinar, where the customer has gone to the retail store to purchase Nutella, and the Cadbury chocolate spread is being offered to this guy because he's coming over here for about long time and he's used to purchase the Nutella. So we should give him the Cadbury as a new product and 50% discount so that he can try. So in the association rules, we try to harness some of the hidden trends from the data, that all right, if the customer is purchasing this particular item, then what is the most probability that he's going to purchase the other item as well. So over here, one of the famous Walmart example, because Walmart is the only retail store which used the assertion rules back in 2000s. So they identified one of the hidden pattern, that all right, if a guy comes over to the retail store and he purchases the beer, then there's a most probability that he's going to purchase the diapers. So that was a very interesting trend from the Walmart, and they used this trend to cross sell other items from the retail store. Then we have another task of dimensional reduction. In this task, the machine helps us to minimize the dimension of particular data. So like you see over here that this image there's an original image in which the 8 is written over here. So this particular image has about 784 pixels, because the pixels are divided on the height and width. So we have 28 over here and 28 over here. So total pixels are 784. So this dimensional reduction model did compress this image in a way that the information is intact. So we can see that the 8 is still written over here, but right now the image is compressed and it is has about 59 components over here. So I'm not talking about the pixels over here. So technically at the back end, the data is being compressed from multiple dimensions to very small dimensions. So we can say that it is compressed from 784 dimensions to 59 dimensions. So another thing we can relate over here, that we have a white light, and this white light is being divided into our 7 colors. So the dimensional reduction works in a way that these 7 colors can be represented with a white light. So that's how it works at the back end over here. Yes, we have a question from Mr. Khan. Said, oye, I thought the webinar is in Urdu. No issues, Khan. This because we have some international audience as well, so we are using English as a primary language over here. But you can ask something in Urdu, and I can answer your questions in Urdu as well. So if you have any questions, you can ask. All right. So this is about the dimensional reduction. So these are the 5 main tasks which I discussed with you. First one is the classification task, in which we try to predict the categorical variable. Then we have the regression task, in which we try to predict the continuous variable. And then we have a clustering task, in which the machine help us is dividing the whole data into particular groups with a similar patterns. Then we have the association task, in which we try to create some continuous rules from the data, some frequent patterns from the data based on some probabilistic model. And then the final task is dimensional reduction, in which the machine helps us in in reducing the dimensions of the whole data so that we can understand it. And of course it will help us in training and computation as well. There are a lot of details behind these topics, but I'm just giving you an overview over here, that what are the major 5 tasks being done by the machine learning, and the whole data science and artificial intelligence moves around here in these 5 tasks. And then there's another buzzword of deep learning. So deep learning is actually an advanced form of the machine learning, in which the artificial neural network is being used, and the concept behind is similar to how the brain of the human works. So it is derived from the machine learning, and it is the new field right now. And for the deep learning, we have a separate webinar which is coming in about maybe 2 weeks ago at the end of Jan. So do go and register for this deep learning webinar as well, in which this particular topic will be discussed. But yes, deep learning is part of artificial intelligence. All right, so let's sum up the thing, that what is the major difference between machine learning and deep learning. So in machine learning, we have the input and we do the feature extraction from it, and the feature extraction is being done by us based on the domain knowledge. So what is domain knowledge? I will discuss it in the next slides when we will discussing the holistic picture of data science. But let's suppose that we are doing some feature instructions over here, and there's a data cleaning involved in it, and then it is given to the algorithm and it does the classification work, and the algorithm learns it, and then it predicts that whether this input is car or not car. But if we compare machine learning with the deep learning, over here we do the feature extraction ourselves based on the domain knowledge. But in the deep learning, the feature extraction is also being done by the model. So there are multiple models being involved in deep learning. One of them do the feature extraction, and those features are given to the another model to do the classification. So over here, everything is done by the model. So that's the basic difference between machine learning and deep learning. And for deep learning, you will dive deep more in the coming webinar of deep learning. So holistically, if we see that artificial intelligence is already part of our lives since about 1950s, because we used to play board games on our computer as well, where the chess is being played with the computer. So the artificial intelligence was already there, and we were already using it for decision making. But due to limitation of data, we were not able to harness that much amount of information from it. But in recent years of 1980s and 1990s, when the internet is over here and accessible to most of the people, the machine learning is being evolved from it, and the mathematical models is being transformed into the computer languages from which we can do solve some of the business problems of or some business challenges of the world. So one of the challenges which is being showed over here, that whether this particular mail is spam or not. So if you are an old guy and you know about the Yahoo or the Hotmail platforms in previous days back in 1990s, they were already able to identify that which particular email is spam and which particular email is not spam. So of course the decision making was done at that time by the machine as well. So in the recent decades of 2010s, after 2010, the deep learning has been evolved in which we are able to solve much complex problems related to computer vision, related to the natural language processing. So yes, the new field is over here is deep learning, but the thing I want to convey over here, that everything comes under the artificial intelligence umbrella. So technically, all of this is same, and it comes under artificial intelligence. There's nothing big difference between deep learning and machine learning and artificial intelligence. Everything is related to each other. So over here, that's all about the artificial intelligence. Now I'm gonna discuss what is data science. So before that, I'm gonna answer some of the questions being given over here. So we have a question from Imran, that I'm working as a learning and development manager, and at the moment we are exploring people analytics, learning analytics. Hence, I would like to know what specific knowledge and skills I need to develop myself in this field. I have basic knowledge of learning analytics, but want a systematic approach to have a better understanding. All right. So Imran, I think your question is gonna be addressed when I'll be discussing that what are the skills and tools required to do an analytics and data science job. So that will be coming shortly. Then we have a question from Sohail. Can we guess an expectation that there will be a booming era of AI? Currently, I think AI is not so much introduced in Pakistan. And what if the AI becomes a dominant for labor, where they will go for their living? All right, Sahil. So right now, many people think that AI is gonna transform and we're gonna lose the job. So AI will be everywhere. Um, I don't think so, because the AI is actually transforming the job market. So they are the new roles which are coming over here after AI. So there's a lot of discussion on it. Like if you can see that previously there was no role of data piracy or data policies. So the people are transforming themselves to based on the security, that what is the data security over here. So in recent years, information security is a new field which is being derived from this particular AI field, because the data is being generated, so it should be secured. So people are specializing on this particular data privacy and information security, that how this data should be made secure. So I would not say that the labor will go home after AI. Actually, they will have to transform themselves into new demand of this particular scale. So don't think that the jobs will be gone, but actually those jobs will be transformed. So of course you need to upgrade yourself and transform yourself as well with the latest trends as well. So I will not say that AI vanish the jobs of the labor. Okay, so then we have another question. Please tell us about feature engineering for prediction and on which domain we do feature engineering. All right, feature engineering is coming right after this slide. Then we have Redmi 5 already. I think that's can we get the certificate of this webinar? Sorry, we won't give the certificate for this webinar. Then we have Fatma Bukhari. Is there a difference between ML and AI? If yes, then an example. All right. So there's a big difference between ML and AI. So AI is actually the whole cloud in which the machine learning comes. So the primary difference is that in machine learning, we follow a process of whole training the machine based on the previous data. But if we talk about AI, it was present for about a decade, and AI can be done based on the rule-based statements. Like if we define a rule in a particular machine, then it can work intelligently. So there's a term we can call it in this era is robotic process automation. So let's suppose you are doing a job on Excel files daily on your computer, and it's the same copy paste job you are doing daily. So how about we record all of your clicks and all of your keyboard strokes from the system, and programmatically design the program in a way that how your mouse and your keyboard strokes are being done on the computer screen. The backend program should work in the same way, and that program is able to control your mouse and control your keyboard. So that work which you are doing daily on a routine basis, and you are not doing something new in it, and sort of I can say that it was an operational job that you are doing on your laptop, and you might get got have been bored from it for about a week, that all right, I'm doing this same copy paste from here and then same copy paste from here, then I'm writing the same thing over here again and again. So why not I automate this thing? So the automation already existed in the industry for about last 50 to 60 years. So that's AI. So in that automation, if we want to embed the decision making by for a particular new change in the system, so that's where the machine learning comes, because it's gonna learn from the historic patterns that if something new happened, that what decision it should take. So that's the primary difference between AI and ML. In ML, the decision making is being done. In AI, it's not necessary the decision making should be done. There can be some hard coded rules to the machine, which the machine can do till we want it to do. So it's gonna do that task till infinity.
Sorry, I'm interrupting, but
Yeah.
attendees who will attend 70 to 80% of the webinar will receive a certificate.
Oh, sorry. I think my marketing team
It's
has
okay, it's okay.
told us. It's okay. All right. I think. Okay, so there are some feature engineering questions that I will address shortly. Then we have anonymous attendee. ML is a is a subset or subfield of AI. Yes, it is a subset and subfield of AI, which I showed in the previous slide over here. That yes, it is a subset of artificial intelligence. ML is the subset. All right, so Fatma got it. All right, so let's move ahead with what is actually a data science. So data science, as I mentioned over here, that it is actually based on data. And if you call someone a data scientist, he or she should have a combination of all these skills mentioned over here. So the first skill over here is called a domain knowledge. Now, what is actually a domain knowledge? Domain knowledge is a knowledge to a particular field. Like, for example, if you are working in a health industry, you are a doctor, then of course the domain knowledge of a doctor is, let's suppose he is an eye specialist, or maybe he's a heart specialist. Then the doctor has studied this whole field of the diseases, the heart diseases or the eye diseases in his degree, or maybe the specializations he has done. And he's also working with the patients, identifying the diseases they are encountering on a daily basis. So he's doing the job, the doctor is doing the job since about many years. If we can say that the doctors is and doctor or the medicine domain existed for about many years, that they used to help the patients and make the recovery of the patients. So of course that's a particular domain. So right now I'm not doctor, so I can't do the heart surgery because I don't know how the heart surgery is being done. So that's a particular domain. So I don't know that. So that's why the domain knowledge is very, very important in data science, because let's suppose if we want to create a model which can detect the heart disease in a particular patient, then of course we have to learn the symptoms and different parameters the doctor is actually using to identify in the patient. So we have to learn those patterns from the data, and we will ask and discuss with the doctor that all right, we do the question asking that all right, what are the basic patterns, what are the basic tests are involved in identifying that if this particular patient has a heart disease or not. So of course the domain knowledge is involved. If the domain knowledge is not being considered, then I will say that the data on which we are working, which is related to the heart patients, we will not be able to understand that what this data is telling us about. Like take an example of the X-ray scan. In the recent pandemic, many people were sharing on the LinkedIn that we have identified the COVID using the chest X-ray scan of a patient, that if this particular patient has the COVID-19 or not. So of course, if I look at the chest X-ray, though, if I'm not a doctor, I won't be able to understand that what I'm looking at, is it good or is it bad. But the doctors help us, the engineers, the machine learning engineers or the data scientists, to identify that all right, this particular chest X-ray is not good, so it's suspected to be a COVID-19, and this particular chest X-ray is good to go. So if you look over here, the lungs look like this and that and many things else. So yes, the domain knowledge is very much involved in understanding the patterns in the data. Then the other skill over here is the computer science and IT skills. So in particular, I can say over here that it's a programming skill. So because we are interacting with the machine, so we interact with machine based on some programming. So right now I'm running this Windows machine or maybe a Mac machine. So there's a whole program which is being running at the back end so that this machine should work. And similarly, if I'm interacting with you on Zoom, then there's a whole cloud-based program which is being working at the back end on the internet to interact with you. So you guys are able to communicate with me. So of course, the computer science and IT is involved over here. Then we have another skill, which is mathematics, math and statistics, because all the algorithms are being based on the math. So whatever decision making is done, it is being programmed algorithmically based on some mathematical equations at the back end. So if we merge all these three fields, the field we told in today's decade is data science. So there's some overlaps between fields which I've mentioned over here. So let's suppose that we have an overlap of computer science and domain knowledge. So that's called a software development. And in software development, I can take example of designing the app. So while designing an app, the Android developers should know the user journey, that if the user will click this button, that on which page the user will go. So of course the domain, the guys who are making the app for a particular problem, they're gonna tell the software engineer that all right, how the user should interact with the app. So the user journey will be known to the programmer over here. So that's why this particular thing is software development. Then we have another field over here, which is traditional research. So the traditional research is based on if a particular guy has a mathematics experience and a domain knowledge experience. Sometimes we also call these traditional researchers as data analyst. And if you have attended our previous two webinars of MS Excel for the business analytics and the data warehouse, those particular webinars are based on an analyst role. So they told you that okay, if you don't know programming, you know Excel, that how you can do the analysis. So of course in analysis the basic statistics is involved. Like for example, if I take some examples of the stats, like what is the measure of center? So we define the measure of center as mean, median, mode. So we studied in every profession. Maybe if you have studied mathematics, so you already know what is average. So average is actually a mean, and there's another measure of center which is median and mode. So some basic statistics are involved over here. But if we combine the computer science and the mathematics, so these guys do the machine learning. So they are actually called the machine learning engineers because these guys are able to transform those mathematical models built on the paper into a programming language. So the data scientist leverages the models made by the machine learning engineers, use them to solve any type of business problem. So that's the holistic picture of whole thing. It shows you that how vast the data science field can be, because he should know the domain knowledge as well. So if he don't know that, if he's working on a particular problem, then of a particular domain, then he should gain this knowledge from any guy who is already present in that domain. Then he should acquire some computer science and IT skills, and he should also acquire some mathematics skills, so that he's able to understand that what are the models built by the machine learning engineer should be used in this particular problem. So it's a combination of these three fields over here. All right. So before discussing that, let me answer some of the questions. All right. So we have a question, sir, if you want to go in data scientist, so many question is how many years I will work to become a pro in data scientist field? Okay, so I would say that this is a very subjective question. It totally depends that what is the learning power you have for this field. Because if I say because this field is very vast that you have to learn every day. You can't say that if I've done this particular master's degree in data science, or maybe I've done this particular course or specialization, I will be called a pro data scientist. So for to be a pro data scientist, it doesn't mean that everyone is pro. Everyone is pro of their own domain. Like if I've worked in the telecom field and I have worked in the HR analytics field, so I'm pro in that particular field, but I haven't worked yet till in much in the banking field right now, or maybe in the healthcare industry. So of course I don't have much knowledge about healthcare industry and the banking industry. So if I become a data scientist of a banking industry, then first I should learn that how the bank actually work, how the all the financial models of the banking work. So yes, you can say the a pro data scientist for a particular domain, but you can't say a pro data scientist for all of the domains. So that's why every data scientist is learning at every part of the career. So this is a continuous learning field, and you should also have an aptitude of learning every time in this particular field. All right, so we have another question. According to you, who can become a good data scientist, programmer, or the domain expert? Um, I can say domain expert, but yes, programmer can also become a good data scientist as well, because he knows how to interact with the machine. So what the programmer can do that he become a machine engineering engineer first, because he is good in programming. So he can program the mathematical models in a good way. So after that, doing the machine learning engineer part, he can learn the domain with the passage of time, and he can also become a good data scientist with a domain experience as well. Then we have another question. How much statistics do you need to learn to be a competent machine learning engineer? To be a competent machine learning engineer, you should have idea about the multi variant calculus and linear algebra. For the statistics, I would say that if you know about hypothesis testing, if you know about the t-distribution, normal distribution, and using the right Mayer of center for a particular data and right Mayer of spread for a particular data, then yes, that's basic statistics is enough. But of course, the statistics is a very wide field. Like for the statistics involved in the time series is a bit different, where we do different analysis, and for the non-linear problems is different. So of course the statistics is very broad. There are many hypothesis testing tests which right now I don't know. I know some of the hypothesis thesis tests, but yes, it is a wide field. So some basic statistics, just like I mentioned, that the hypothesis testing, in which we see that if this particular variable has some sort of relation with the other particular variable, if you know hypothesis testing and how to use it to define the relationship between the variables, then that's a good enough statistics to be used. And also the statistics is also used in some study design, that if you are working on a very big population, that what are the sampling techniques you should use in it, how the samples should be used, and what are the measures you should use as a parameter or the sampling techniques. And the A/B testing is also part of the statistics. So yes, whatever mentioned, the terms I have mentioned over here, that are good enough to be a computed machine learning engineer. All right, so let's discuss the whole data science flow. Some of the people were asking questions that how the feature engineering is being done. That will be addressed in this particular diagram. So most of the people think that data science starts from the data, but I'll say no, it doesn't start from the data. Some of the companies say that, all right, we have lots of data, so we should do data science. No, that's the wrong thing. Data science always starts from a problem statement, from a question. So if you don't have a problem statement, then there's no need of a data science. So to start a data science, there should be a particular question. So based on this question, we acquire the required data to answer these questions. So that data is being acquired. So acquiring part is being done using the data warehouse, or maybe big data, or you can say you can do a web scraping from a website, and that data is being acquired. And when it's acquired, it is being ingested. If the data is very small, you can use it on your laptop. If the data is very big, or you can say it's in maybe more than terabytes, 100 terabytes. So we don't have a hard drive of 100 terabytes on laptop, so we use some ingestion systems. So we discussed the ingestion systems in the last webinar, which is data warehouse, and you're gonna discuss some of them in the next webinar, which is big data. So big data is also an ingestion system. So the data is being ingested, and then the data science team or the analyst team extract this data, and then they used it for the wrangling and exploratory data analysis. So over here, the wrangling part is termed as the data cleaning part, and we also do some feature engineering from it. So feature engineering is actually a part in the wrangling where we extract some refined variables from the data already available in this ingestion system, so that that new refined variable somehow is able to answer this question. So in a simpler way, that's the feature engineering, that you extract a refined variable from the data, and that refined variable is extracted in a way that that particular variable is able to answer this particular question efficiently. So we do the analysis of those variables over here as well. So this whole process of wrangling and visualization is called exploratory data analysis. So the statistics is also involved in this step, where we do sometimes the A/B testing, the causality analysis, the correlation analysis, and the hypothesis testing as well. So we try to see that if the variables extracted over here for this particular question, that how the relationship is being made over here from the variables with the question which are being given by a particular domain. So we try to extract as much information as we can, and then we know that what are the relationships over here based on the question, which are being derived from the statistics, but we want to automate these whole scenario using a model. So as I told, that the artificial intelligence is being used to automate the decision making. So right now for this particular question, we have to do some decision making. Let's suppose the particular question is that, all right, we have a football match of Real Madrid and Barcelona. So who's gonna win the match? So we want to predict that who's gonna win the match tonight. So for that we have to acquire the data. So we will acquire the data from all the websites that all right, what are the previous matches results of Barcelona, what is the previous match results of Real Madrid, who's the captain, and there's many dimensions involved over here. And we try to make some relationship with all variables with the result of the previous matches, that all right, if these particular 11 are playing them in a match, then this team is gonna win. If the match is home, then this team is gonna win. If the match is away, then this team is gonna win. So based on that, all the variables are collected, and we try to see the relationship of those variables with the question we are being given, which is that who's gonna win the match. So we got some sort of answers over here, but we want that those answers should be automated and learned by the machine. So that's why we use the modeling part over here. So we give the data to a particular model. We choose a model as per the problem statement, and that model is being trained, and then that model is being validated that if it is working in the right way, it is making the right decisions or not. If it is not making the right decisions, we go back to the choose step and choose another model which is more efficient to learn. And when we are confident that the model has been trained and it is able to do the decision making itself, then we deploy the model on a particular website, and where we go and give the required data and ask it that, all right, who's gonna win the today's match. So that model is being deployed. But we keep on testing that model in the production as well, that if it is still giving the right predictions or not. So let's suppose if it doesn't give the right prediction, then we go back to the modeling step and try to retrain the model, that maybe there's not enough data when we trained it previously, or maybe there's some changes in the features, so we might go back to exploratory data analysis as well. So we will do this modeling part again after knowing the new patterns in the data, and we will deploy it again and keep on testing it. So in this whole data science process for the particular problem, of course, the last part comes is the storytelling. So the storytelling part is also being done over here, because this is a very unique part for a data scientist, because he want to explain all of these techy stuff in a non-technical manner to the required audience or maybe the management, so that they are able to understand in a crisp way, or you can say in a simplified manner. So the data scientist can't explain that, all right, this is the mathematical equation, and if we input these variables, that's how it's going to give the answer. So the management is actually non-technical. They are actually the people leaders, so they don't go in the technical stuff. So we have to do a storytelling in a way that they are able to get the idea that how this particular problem is being solved. So now if I divide this whole process into the particular roles available in the industry for this data field, so the question is being given by the domain owner. So the domain owner can be anyone. Like for example, if I take the example of the Real Madrid and Barcelona, so the domain owner will be the club owner, or maybe the club manager. He is the domain owner. He knows that this is a question, and he knows the previous past matches results as well, so he has the domain knowledge. So that business owner is gonna give the question. So the data scientist and why my laptop is stuck. Okay. So we have another role of data engineers slash data scientists. So primarily the data engineers is gonna acquire this data and ingest this data. But you will be thinking that why I have written data scientist over here. I have written data scientist over here because the problem statement is being given to the data scientist. So he has to supervise the data engineer so that the right variables for this particular business question are being extracted, are being acquired, and then ingested into the system. Then after that, this exploratory data analysis part is being done by the data analyst, and it can also be done by the data scientist as well, where they try to find the relationship between the variables which are being ingested over here and relationship of those variables with this particular question. After that, the modeling part is primarily being done by the data scientist as well, or it can also be done by the machine learning engineer as well, where he get the data from the analyst and model it in a way that it is able to do the decision making from the machine. Then after that, the deployment part is primarily done by the DevOps, but it is being supervised by the data scientist as well. So it is being deployed. Maybe it is deployed on our website. Maybe it is deployed on the Amazon Web Service. Maybe Microsoft Azure. There's many things. So in the next webinar session, you will also know what is DevOps. And after that, the model is going to be tested by the data scientist and the business owner as well, because we are solving the problem or question for the particular business owner. So we are solving the question for the club manager or maybe a doctor, so that the doctor can identify that if this particular patient has disease or not. So of course, the decision making is done by the human before the machines. So they know already that how they are working. So the business owner plays a primary part over here in testing this model in the production, that if the decision making is being done by the machine correctly. So if it is not being done, then as I said, we go back to the modeling part, or we go back to the exploratory part to extract the new relationship of the variables with this particular question. And yes, the storytelling part, in the storytelling part, the data scientist is also involved, the business owner is involved, and the data analyst is also involved, because the data analyst helps the data scientist in making the right visualization for the data. So yes, the data analyst can also be involved in the storytelling, because he's also working in collaboration on the exploratory data analysis part with the data scientist. And of course, business owner is the owner of this question, who is trying to solve this problem. So he is also part of the storytelling. So over here in this whole diagram, you can see all the buzzwords of the roles present in the industry. We have the data analyst role, we have the data engineer role, we have the DevOps role, we have the data scientist role, we have the machine learning engineer role. So in this whole figure, I'm trying to tell you that how the involvement of the data scientist is being done in all the stages of the problem. So over here, the data scientist technically is also involved, because the question is given to the data scientist. The data scientist is present over here as well, over here as well, and here until the end, till storytelling. So this whole process gives you a holistic picture that it's not an easy job to be a data scientist, because the data scientist should know every step of this whole process. So based on that, in the next slides, I will discuss that what are the skills required by a data scientist, and how we can compare the data scientist with the other roles in the industry in terms of skills. So that's all about the whole process of the data science. And I can say, as you see this whole process, this is the whole process being followed by me right now in the industry. So I'm right now working on a particular problem where I am acquiring the data, because the role I am in right now, I'm doing this whole job by myself. So I'm acquiring the data as well, I'm ingesting it as well in an SQL server, I'm doing the exploratory data analysis part as well, then I'm doing the modeling of that particular problem and decision making, that I'm also responsible for deployment, and I'm also responsible to keep testing the deployed model as well. So primarily, data scientist has to learn all the skills required in this diagram and to do the job, necessary job, because in some companies, the data scientists are confined to the modeling part only. They are responsible for modeling part. But in some companies where there's a new team of analytics, so the data scientist there, so there's no data analyst over there. So the data scientist is being required to do all of this flow and all of these jobs of data engineer, data analyst, and DevOps. So yes, it's a very wide field. So let me answer some of the questions which are being received. So we have a question from Bernard from Kenya. Will there be a video of the webinar available after the webinar? Yes, Bernard, the video will be available on our Facebook page of Dice Analytics. The recording is being done. All right, then we have a question from Iran. Can data science be used to determine the return of investment of trainings. In tangible terms, can we know how our employees are improving through training interventions? Yes, Imran. We can know that how our employees are improving by defining some of the pulse surveys, or maybe defining a, I think this question is more related to the employee development. So we have some performance management system in the company. Maybe you have a performance management system, or maybe you have a performance measurement system in the company. So based on the performance, you get the feedback for the particular employee through the line manager, which is being logged in the system. So based on that feedback, we try to see that how the performance is being done by the what are the strengths and weaknesses of this particular employee. And we can see that if there are some weaknesses, then based on those weaknesses, what type of learning interventions are being done by the particular employee, and in what learning and development platforms we should invest, so that the skills of the particular employees can be enhanced. So I think it's a long discussion, but yes, data science can be used, and I have done the predictive learning for the particular employees myself by identify the weak areas of the employee from the feedback, and based on the weak areas, um, um, uh, I actually built a recommendation engine from the LinkedIn Learning and Coursera. So based on the weak learning areas, those keywords were being searched on the LinkedIn Learning catalog and the Coursera catalog, and the nearest courses were being emailed to the employee, and we actually monitored them at the back end, that if those courses were being taken by the employee or not. And of course, all the LinkedIn Learning courses and the Coursera courses have assignments and the grading system at the back end, so we can monitor them that how the assignments is being done. Is there any deadline which is not being met by the employee during the course? So yes, there's a long discussion backed on the return of investment of trainings. I hope you have got some of the idea of it, what I'm talking about over here. Then we have another question: what is the training and testing ratio of taking data set to split data into training model? As a thumb rule, the training and testing ratio is being taken as 80-20%, but it is another discussion which is being discussed in the course which is being offered by us at Dice Analytics. So there's a whole lecture on it, that how the training and testing ratio is being decided. But on a thumb rule, it is 80-20% or 70-30%. But yes, there's another technique of model selection involved, and we try to evaluate that if the model is learning it or not, so we can change it based on the need, and that's whole new discussion. Then here we have another question. Can I ask where business analyst fits into this process? So yes, as I told, the business analyst fit in this process over here in the exploratory data analysis part. So I hope this question is being answered to you already when I mentioned all the roles in this whole process where they are fitted. All right, so can you share recording on YouTube? Yes, Priyanka, the recording will also be shared on the YouTube after this webinar, and it is also being shared on the Facebook. Then we have question from Dharik. What is the timeline to become data scientist in the 4 years of engineering? I'm in second year. All right, Dharik, as I told you that to be a data scientist, you should also have some sort of domain knowledge. So as I told you over here, that these are the three basic things should be acquired to be called as a data scientist. So if you have a only computer science skill and you don't know about mathematics and domain knowledge, then you can't be a data scientist. So as a fresh student, you can be called as a machine learning engineer because you are learning some computer science skills and mathematics skills, and you might be learning some of the modeling techniques in your maybe bachelor's. But you can't be called as a data scientist because you don't have a domain knowledge in a particular industry. So to be called as a data scientist, you should have some sort of domain knowledge, and that can only be acquired if you work in the industry or you use some of the platforms where the problem statements are being used and they are used being solved the real problems that I will show you in a moment. All right, so let me have a look at a chat. Aruj is asking, can you share about round one and two? Aruj, you can go to the Dice Analytics Facebook page and have a look at the recordings of round one and round two webinars. Okay, so let me show you the practical data science flow over here in a short way. So I'm gonna open one of the tools I'm using over here. So this is a tool I'm using to do data science on my laptop, and this particular tool is called Jupyter. And at the back end, we have Python, which is being run in the Jupyter. So if you have seen it already, you might know this interface, but that's how this is the notebook environment in which we work. So right now I'm gonna go through one of the image classification tasks done using this whole process over here. So in the image classification task, we are building a model where we're gonna identify the digit from a particular image. So this is a very famous data set of MNIST, and which is called Modified National Institute of Standard Technology Database, in which many people have contributed by writing a handwritten digit. So you can see the collection of handwritten digits over here, which are from 0 to 9. So first of all, we did some collection of the data. So this data is widely available in one of the Python libraries, which is called Scikit-Learn. So I acquired the data from this library, and here I'm acquiring the data, which is a Python code written over here of fetching some OpenML dataset. So over here, the acquiring part is being done, which I showed over here. Right now, the data is not that big, so I can acquire it on my laptop. So there's no ingestion technique or ETL technique I can say over here. So the data is over here, then I'm checking that, all right, though there are 70,000 images over here, and there are 784 columns in the X, and the Y has also 70,000. So let's have a look at the content of X. So in the content of X, we have a look at the first record over here. So there are some values in zeros and 126, 25. Right now, I am not able to infer something out of these values. I'm just looking at it, and if I tell you that what this data is actually representing over here, let me show you a bit. All right, so in the MNIST data, we have a particular image over here, and they have already told us in this particular data in the documentation that this image has 28 pixels in the height and 28 pixels in the width, and we have one of the digit written in this 28 by 28 pixel image. So this particular data set is available in a flattened way, in which this whole image is being flattened. By meaning of flattened means that this whole image has all the pixels over here. So I can say this particular box is 1 pixel, which is being represented by 1. Then we have 2, and then we have 28 pixels over here. Then we have also numbering over here, which is 2, 3, and 28 pixels over here. So if I tell that how many pixels in this particular picture, the total pixels over here are 28 by 20 multiplied by 28, which accumulates into 784 pixels. So total pixels in this particular images are 784. But in this scenario, they have flattened the image. So what is flattening? Flattening is a process in image processing where the image is being transformed in a linear. You can say that this is a two-dimensional image. So the two-dimensional image is being transformed into a one-dimensional image in a way that all the pixels are represented in this particular array. So the data right now I have over here is already in a flattened form. So in this flattened form, I'm not able to know that what this data is actually telling me. So it means I have to do some sort of wrangling part over here, which I mentioned is the exploratory part, the wrangling part, and the visualization part. So Then I have looked at the, all right, what is y0? So y0 is saying that, all right, whatever over here in this x0 is, that is actually the number 5. It is a digit 5. Now I already know from the documentation that this image is being flattened, so it is converted from 2D to 1D. So to actually get the information out of it, I have to plot it in a way that I convert it in a reverse way. Like I convert it from 1D to back to the 2D. So over here, I'm converting in this code the image in from the flattened one to a 2D dimension one. So right now using this code, I'm displaying the first 10 images over here, and I'm also displaying the Y label over here. So the first image which is being showed over here is 5 in the image, and the label is 5. Then we have 0, 4, 1, and 9. So now I know that, all right, what is inside this data. So now I have to see that what this particular image is being represented in terms of the pixels. So now I'm trying to visualize one of the image, and I see that I visualize it in a way that all the pixels are being represented in their own value. So I use this whole code to build this visualization, and now I'm able to see that, all right, though if the pixel is 0, then it's black, and if the pixel has a big value like 253, so I know that the pixel has a maximum value of 255. So over here this is a white color, so the 253 is represented. So if we have a bigger value, then the bigger value is being already been present in the line of the digit. So the digit is being represented in the form of big value of the pixel. So the smaller value or the less, this is the black color. So now I know that, all right, these are the values which will be learned by the machine learning algorithm. So now I do the train test split. Now I have done the exploratory part. Now I'm coming back to the modeling part. So for the modeling part, I'm dividing my data into train and test. Over here, I'm using a 15% test size. It means that I'm using 85% data for the training process and 15% data for the testing process. Then after that, what I'm trying to do is using another dimension reduction model, which is called a PCA. So right now I have a dimensions of 784, but I'm applying a PCA model which is going to reduce the dimension. So here I have applied the model. Now after applying the PCA model, you can see the 154 is written over here. So right now the dimensions are being reduced from 784 to 154. So based on these 154 dimensions, I'm gonna train a model. So here I'm importing a famous model which is called Logistic Regression, and then I'm building the model over here. And here the training process is being started. So model is being trained. After training the model, I do the prediction on the test data. So after doing the prediction on the test data, I am actually comparing the prediction with the actual data. So right now the model is 91.4% accurate, and after that I'm trying to evaluate each digit, that how good each digit is being predicted by the model. So these are some performance metrics which is called precision, recall, and F1 score, and they are being used to evaluate a model in the classification problem. I can't tell the definitions right now because that's a separate discussion, but I'm just showing you flow that how the work is being done. So over here, I am seeing that the number two digit have a bit low score. Similarly, number 5 is have a bit low score, and number 87 have low score. So it's because they have similar type of patterns in the digit. So there's bit performance degradation in these particular digits, but overall model is performing good. Then I have a look at the weightage F1 score, which is also being displayed over here, but I'm trying to look on it in the decimal places. After that, I saw that, okay, I have applied a dimensional reduction model, but over here by default, I used a 95% variance of this PCA model, which translated these 784 dimensions into 154 dimensions. So now I'm gonna optimize my model and use try to tune the model in the best possible feature in the best possible features being extracted. So over here, this whole code is being written, and from this code I'm trying to doing the selection of the model, because I'm trying to validate it over here, this process of continuous validation and choosing the model. So I'm trying to choose the right PCA model over here. So here you can see that 7 models are being created, and all the 7 models are being evaluated by me. So over here, the first model has a variance of 1, which means all the data is being used, which is 784. The training time taken is 46 seconds, and the accuracy score is 92%. Then I reduce the data to 331 components, then 154. I can see the training time is still huge. Then I saw that at 87 components, then the time taken to train is 19 seconds, but still there's not much degradation in the accuracy, and it is fairly able to predict the test images even with 87 components. It means if I use 784 components or 87 components, there's not a much big difference in over here. It's just difference of 0.05%, so I can bear that. And after that, I see that there's a drastic change in the score at 59 components. So I can see that the accuracy has started to decrease. It means the model is not performing very well. So I will choose the one of the model over here with the 90% variance, where I am using 87 components to train the model. So I choose the final model over here. Now if I have chosen the final model, so I need to extract this model and deploy it. So I have chosen the model. Now I have to deploy this. So for deployment of this model, I'm gonna export the train model. So over here, I'm exporting the train model. I'm doing the training on the 90%, and the model is being exported. Similarly, for the PCA as well, and then the classification model is being also exported from here. So I want 2 models. One of them is dimensional reduction, and one of them is the classification model. So I'm using a combination of 2 tasks over here. After exporting, I have saved those model, then I'm gonna use it to deployment. And finally, I'm trying to see that, all right, how the image looks like, because the model is making decisions based on 87 components. So how the image looks like with the 87 components over here. So in the end, I'm trying to see that how the decision making is being done by the model. So I see that, all right, I have chosen the 90% variance. So 90% variance represent about over here the 87 components. So I can see there's a lot of components over there, but the variance explained by them is not adding much of the values. So I can do the decision making on 90%. And after that, I'm trying to see that how the image looks like with the 90% explained variance. So over here, this is the original image, which is 8. Then we have a 99% data. The image looks like this, which is fairly good. Then we have 95% data. The image looks like this. Then we have 90% data, and I can also read 8 over here. So yes, the machine learning model is doing the right decisions, but at 85, there's the image is getting blurred. Although as a human, I am able to read it, but the machine is not able to do it. So you might be thinking that if you have heard about the convolution neural network, or maybe the deep learning thing, that why I'm not trying to apply. So yes, I can use an advanced technique of deep learning where I can build a neural network so that the accuracy can be increased more, maybe to 98%. But over here, I'm just trying to show you that how I'm doing this whole process. So I've acquired the data, I did the wrangling, visualization part, then I did the modeling part, and now I have deployed it. Now I have deployed this model on the Flask. So I'm just gonna run this model for you guys locally. So I'm gonna open my command prompt, run this as admin. And I have that model available on this particular path. So I'm gonna this path over here. And then I'm gonna run this. Actually, I'm running this on a particular deployment platform, which is Python based, and it's called Flask. You can search Flask, that how it's works, but I'm just gonna show you deployed version of this model. So we have app.py over here, and I'm gonna run it. All right, now it's saying that your application is running on this particular ID. So I'm gonna going back over there. And I'm gonna write this IP. Oops, sorry. All right, so as mentioned over here, my model is running on this particular local IP. So over here, I have designed this whole interface of the deployment where I'm gonna choose an image. So I have some sample images over here on which the model is gonna predict real time that, all right, which digit is that? So let's say I choose this image and I open it. So I made an interface, a web-based interface where the image is being opened, and then when I click this predict button, the model is gonna predict it at the real time that which image is this. So when I click the predict, it says that number 9 is being displayed. Then I choose some other image like for example, let's choose this one, which is a tricky one. Let's predict it. So it's 5. So I can see that the model is behaving good. Let's choose this one. This is 7. So it's sort of a not that good 7. So let's predict. Oh, it's working. So now I have validated this test part as well. So this is the whole process, and I just just shown you a glimpse of this whole process in a particular notebook and the deployment as well, that how it's being done. Now let's move to a video, and you can see that how a data scientist work in a particular day. And after this video, I'm going to address questions and do some closing remarks and tell you that what are the skills required to be a data scientist and how the skills are different from other roles. So let's just watch the video.
We live in a world where technology has advanced so that we can collect huge amounts of data. The human mind does not have the ability just to look at tables and tables of data and just draw some conclusions. So data science is a logical way of being able to identify the structures that are inherent in that data, understanding the business problem, doing the analytics, and then providing some sort of a solution. My name is Alina Corvello, and I'm a data scientist at Chevron. Data science is an interdisciplinary approach for extracting information out of data in order to make better decisions. The team of data scientists is a pretty diverse one. There are people that come from maybe the more traditional background. They have a statistics degree or computer science degree. But then there are people that come about it from the other way of having a deep knowledge of the subject matter. Math is beautiful because the relationships and the way that it could be used to solve problems and all these different areas. I always say that data science is about more than just data scientists. We're working with people to help answer their questions, give them information that we can from their data. That involves developing training materials, actually giving the training, and then perhaps working with people one-on-one to identify what they need to do to build their skills in that area. One of the things I like to do when I'm teaching is to take technical concepts from the class and then tie them to things that people might be more familiar with in their everyday lives. I use some examples from garment construction. There's a lot of engineering in creating a garment. You have a flat pattern and you've got to think of how to construct it in a three-dimensional way. Data science takes data and tries to find patterns in the data to answer questions. The data comes from a variety of sources. It could be from the incident investigation and reporting. It could be from reliability databases and inspection records, maintenance records, and then also operating data. The kind of problems that I work with are trying to affect or to improve process safety. And so that's helping us be more proactive rather than reactive. I'm excited about the future of data science at Chevron. It's gaining a lot of momentum. I think there's a lot of data, and we're starting to get to dig into it and try to get some insights, and I'm really excited to see where it takes us.
All right, everyone. So you can see that the data science can be applied in the fashion industry as well. You can see that how she is applying data science to build the clothing, and it is helping out in finding the hidden patterns in the clothing. So yeah. So before going to the skills required, let me answer some of the questions which are being given. Um, Okay, so we have question from Samia. Is webinar offer different sessions for computer languages like Python, R, and C, and from we can learn data science more briefly. So I just given a brief session of Python, although I didn't explain the particular code, but I just showed you that how the whole flow is being done. Yes, we can plan to do some webinars where just we make you learn a short snippet of Python and R or maybe other languages. So yeah, I hope it's answered. Then let me have a look at chat. So we have a question from Malik Hashir. What is meant by good understanding of data set? When it is said that one should have a good understanding of data set being used, what kind of understanding is required? So Hashir, the kind of understanding is required that you have a domain knowledge, and you know that if one of the variable is changing and it has some sort of causality or correlation with the other variable, then why it is present over there. Like if you have a question that we have a question like the sale of ice cream increases when there's a fire in the forest. So you need to understand that is there any relationship between the sales of the ice cream and the fire in the forest or not. So of course, if you have the domain knowledge, then you will be to identify the relationship from the data. So you have a data of two variables. One is the sale of the ice cream and one is the fire incidents in the forest. So if you don't understand them based on the domain knowledge, you won't be able to infer something of it. Maybe you will, the patterns will be saying that, all right, the ice cream sale is increasing and the fire incidents are increasing, but are they really related? So technically, we try to find the confounding variable between the two variables and try to identify the relationship between them by using the causality and correlation analysis. So yes, understanding the data set is really important because you can't be called a data scientist unless you have a domain knowledge. Then we have a question. I am a commerce graduate, but I want to switch to IT data science. From where I can start? Thank you. Um, um, I will tell you that how you can start. You want to switch to IT. So as a commerce graduate, I think you might have not done some sort of programming. So I'm gonna guide you at the end that what the non-programmers who are not from programming background should learn, how they can learn data science as well. Okay, so we have another question from Harsha. Let me answer that also. Also, I want to ask, one course is in progress at Dice Analytics. Do you plan to start a new one? If yes, then how? All right, so keep following us on the Facebook page and on LinkedIn, and you can also check our website. So the new course will be starting soon, maybe in the first week of Feb. So keep following us and you will know when our course will be starting. All right. So let's come to the final thing that what tools are being required to be a data scientist. So if you search the Google, you will find lots of tools, but for the simplicity of this whole process, I just want to focus only three tools over here. The first one is Python because that's the widely available programming language in data science right now, which is it is an open source community. So all the models, all the algorithms, most of the algorithms are available in the Python, and it's just not only for data science, but it is a whole package. It has also some web development, web scraping tools, and it has some deployment tools. Just you saw over here, Flask. It is based on Python, so it is a complete package programming language. So there's a lot of things you can learn in Python, not necessarily related to data science, but also for automation as well. It has a library to control your mouse keyboard as well. So I used to do a lot of things with Python. So yes, Python is the high demand skill for to be a data scientist as well. Then you should learn Excel as well, because you have to do some sort of analysis. So I've seen that some people don't know about Excel. So Excel is also primary thing to be a data scientist. And some people will say that no, you should know about the Tableau, or you might have heard about Tableau, Power BI, Click. These are the visualization tools. But as a start, you should know Excel, because if you know Excel, you can work on the latest, you can say the advanced tools of visualization. So Excel is the primary tool of visualization and handling data. And that's what we focused on in the first webinar series. Then you should know Excel. Sorry, you should know SQL. Why you should know SQL? Because in the data science flow, I told you that we have the acquiring part and ingestion part. So if you want to do the exploratory data analysis and the data is available in the SQL server or maybe big data, then you should know the SQL language to actually extract that data from that ingestion tool. So that can only be done when you know the SQL. So what I'm trying to focus over here, that these three tools are the basic requirement to be a data analyst or a data scientist to start with the data science. So that's what the industry is looking into in a particular candidate when they are hiring, doing the interview process or hiring them. So they should have some idea of the Python, they should know SQL, and they are able to manipulate the data in Excel as well, because Excel is used in about almost every field in the industry. So these are the primary things required to get a job in the field of data science. And the remaining are some cherry on the top things. The tools required are the cherry on the top. But yes, these are the basic requirements. And you can find lots of tools like Azure, AWS for deployments, and then you have a Google Cloud Platform as well, which is a deployment part, and they have also some analytics tools and data size track and drop tools as well. Then you have big data. Of course, the big data also works on SQL, so that's why I have covered the SQL. Because but in the big data terms, we call the SQL as Hive language, but somehow the structure is same, but there's a different in the syntax. So that's why I'm emphasizing on SQL. It is required everywhere. All right, now let's compare all the roles I mentioned in the data science flow process. So the main skills of the data field are the programming tools, which I mentioned in the previous part. And then we have the data visualization and communication skills, then data institution skills. One of the questions is being asked by Harshit that how much data understanding is important. So yes, the data understanding is actually the data institution. Then we have statistics, data wrangling, machine learning, software engineering. As you see that I just show you a web-based interface for the digit recognizer model. So yes, at the back end, the web development is being done for this whole deployment particular web page. So yes, software engineering is involved. And then as I told that all the AI models are actually based on the mathematics. So we have multivariable calculus and linear algebra involved at the back end. So if you look at the data scientist role, I have done some legend marking over here, that this dark orange one and the big circle represents very important. This represents somewhat important, and this one represents not that important. So you see over here that most of the skills are very important to be a data scientist. So all these skills of programming tools, visualization, institutions, statistics, data wrangling, machine learning are very important for to be a data scientist. And yes, software engineering and multivariable calculus is somewhat important, because in the very multivariable calculus, the algorithm is being designed, but primarily the algorithm is being made by the machine learning engineer. So the machine learning engineer should be good in multivariable calculus so that he is able to translate that mathematics into a programming tool. Similarly, if you want to be a data analyst, so it's not that much necessary to be a good, that very important to be have a good in programming, but yes, you should be somewhat good in it. But if you know Excel, then you're gonna do the analyst role. You can easily do the analyst role if you know the Excel. Then we have come the data visualization and communication part, because the analyst has to make the visualization to understand the data. And yes, or she should have data institution, and he should have the data wrangling part as well. The one guy you see over here is the DevOps engineer. So is in this whole skills process, the DevOps engineer should be good in programming tools and in software engineering part, because these guys are the one who monitor the deployments and keep on doing unit test on the deployment system. So they are running the backbone of the whole infrastructure for the deployed models by the data scientists, and they are also responsible for the whole infrastructure for the ingestion as well. Although the data is being ingested by the data engineer, so you can see the data engineer should be good with programming. They should be good in data wrangling, because there are some defined business rules in the ATL process which should be mentioned during. So the data wrangling is also involved, and then they should be good in software engineering, because they have to deploy the whole data pipeline on the system. So this whole picture gives you fair enough idea that what are the skills, primary skills required to be a data scientist. And that's why I told you that data scientists behave as an umbrella over the whole process. So if the data scientist is not doing any ingestion part, so the data engineer is guys over there doing the ingestion part, but the data scientist should know that how the ingestion is being done. So this whole picture actually is a new way of showing that how in each of the process the data scientist is involved in the data science flow, which I discussed previously in the slides. Now, if I tell you that what is the scope of data science, so you can see the vast possibilities of applying data science in all the major industries present right now. So yes, it is in technology and startups, and it's in retail, it's in banking, it is in conglomerates and industry, it is in engineering, and it is in health care service, it is in media and creativity. And because in media, even the news channels are also using the data science in identifying the hidden patterns, that if the particular news is being published, then how the audience are being reacting to it. Is it a positive, is it a negative? And similarly, they are also using some of the models to identify the fake news, because there's a lot of agencies who are publishing fake news on Twitter. So yes, media is also using data science. Then we have accounting, then we have insurance, government, regulatory, and law. So you name any industry field, the data scientist is now being employed in all industries. So you should not be worried about it that the data scientist and the AI will come, and the labor will go home. There will be no jobs. So it's nothing like that. Actually, the jobs will be transformed in the future in a new way. So that's all about it. So the webinar recording will be available on YouTube channel. Go to our it will be available on YouTube, so you can subscribe to our YouTube channel for any future webinar and the recording as well. So don't miss the next webinars, which is Big Data or Go Home on 23rd January, and the DevOps, which is on 29th January. Go to the Facebook page and the link provided over here and register yourself so that you can know more about the big data and the DevOps. So yes, now it's the time for the question answers in the last 10 minutes we have. Let me see the chat if there's any question. All right. So Yogi is saying, is DICE Analytics open for internship program? Yes, we have some internship programs, but you need to follow us on Facebook for the post. Whenever there's a program, you can share your profile with us. Then we have Oshari. I'm currently working cost estimation engineer, interested in pursuing higher education and equipment myself with current digital era. What should be the suitable course related to data science that will amplify my current profession? So for a suitable course, I can say that we will offer our course in data science in English language soon. Currently, the courses being offered by us are in Urdu language, but in February we are launching a course in English. So if you are interested in English course, you can join. But if you are interested in Urdu course, you can also join. And there are other platforms as well, like Coursera and DataCamp. You can join them as well, but they are self-paced courses, but the courses offered by Dice Analytics are instructor-led. All right. So how we can get our certificate? Is there sending our IDs which we register? I think marketing team can answer that. Zainab, are you there?
Yeah, can you repeat, please?
Yeah, it's saying how we can get our certificate. Is there he's saying, are they sending on our IDs which we register or any other?
Yes, we are going to email them, the attendees who will attend 70 to 80% of the webinar.
All right, great. Okay, now let me have a look at chat. Okay, so we have a one hand raised by Akib. So Akib, I have allowed you to talk. You can ask question. You can guys raise hand. All right. All right, so we have a question from Shabazz. Yes, Shabazz.
Thank you very much for a wonderful presentation. So basically, I am an engineer.
Yeah.
I have little background of computer science, but for future, I'm interested in this data science. So how much time would I need to become a full-fledged data scientist with very less computer science background?
Well, it's a very subjective question. I will say it will all depend on your on your learning skills and your motivation behind it. As you mentioned that you have a non-computer background, so I will suggest you to keep following our webinar series. There is another course which is being offered by DICE, which is machine learning with a non-coding background, in which NIME software and the Excel is being used. That how you can do machine learning and data science using Excel and a NIME. NIME is a drag and drop tool. So keep following us. There's a 7th webinar series. Go to the Facebook page and you can register it. So there you will have a total know-how that how you can start the data science with a total non-technical background, and you will learn some basic things. And after that, you can totally decide that if this field is really for you. How much time is gonna take? That's totally dependent on your motivation and your learning capabilities on this one. And it also depended that if in daily life you have a job which is related to this field, or if you don't have a job, how much time you are spending in your free time on Google or maybe some extra courses, and how it's all depending on your learning things. So I hope I have answered it.
Okay, thank you very much.
All right, so we have more questions. Someone have raised hands. Yes, Salim.
Hey, my question is, yeah, first of all, awesome seminar. And yeah, my question is, what do you think about the Pakistan industry data? Like, it is mature enough to like for use for a sample work or for creating the test cases, or what do you
Well,
think from the like foreign data or like overseas industry data? Like, if you compare our data with US, which data is more mature to work with the data science or implement
Well,
data science?
I would say that the mature data is already present in the telecom industry in Pakistan, because it is the biggest industry right now in Pakistan, where this, you can say, billions of records are being generated daily, which are being ingested in the system. So it's fairly mature, and this is the biggest industry right now in Pakistan. So yes, we can't compare it with the US, because some of the social media giants like Facebook, Google are already present in the US. So of course they have a very big data, which I showed in the slides, and that how much data they are generating right now. But right now telecom industry is the mature one, and in recent about 1 to 2 years, the banking industry is also now jumping towards this analytics platform. So banking and the fintech industry is heavily investing in this. So right now we have two fintech giants in Pakistan, which is Easy Paisa and Jazz Cash. Primarily they are evolved from telecom industry as well, so that's why they are generating a lot of data. You can see that how Easy Paisa and Jazz Cash are integrated with your utilities and everyday life cycle with your e-commerce website like Daraz. So in the e-commerce, you can say Daraz is also generating fair enough data right now. So I can say these are the three industries right now in Pakistan. First one is telecom, which is pretty mature because it is here for about last 10 to 15 years. Then we have the banking industry, and then we have the e-commerce industry, and the fintech industry. So these four industries have really mature data in Pakistan right now. I hope I have answered your question.
Okay, great. Yeah, you have answered my question. Just want to add one more thing in it. Like,
Yes.
what more industry you are seeing in 5 years to work with? Like, if I start with the banking or telecommunication industry, there there are a lot of people working on those sectors. What you think they like are more like opportunist industries in in upcoming 5 year for data science? Like, you think the medical
Well,
one, or what you or the food chain? What you think are the next telecom industry for the
Well,
data science?
right now the opportunist one looks like in Pakistan is the fintech industry, because they are the one, they are actually integrating with all the platforms, and even the government organization are also promoting the fintech. Recently you have seen that in Easy Paisa and Jazz Cash, the excise and taxation department of Pakistan, where you go and register your vehicle and pay the excise duty on yearly basis. So they have integrated with Easy Paisa and Jazz Cash. So you can see that how all the daily life commodities and utilities are getting integrated with these fintech giants. So in the next 5 years, the fintech is the one which is actually very much progressing in Pakistan right now. And if you are talking about switching the career, so I will suggest that first you need to focus on that what particular industry you are working on it right now, because as an experienced professional, it's not an easy to just switch directly to data science. First you need to see that how the data is being generated in your current company or industry where you are working, and how you can engage with the analytics team, or maybe you can engage yourself from out of the way in your in your daily job routine by learning these skills and start applying it in a short span of time, or you can say mm, very limited for a very limited scope, and try to tell the management of that particular company. Because as an experienced professional like you, like you are asking question, I'm inferring that you are an experienced professional, so you already have a domain knowledge of your own particular department or company where you are already working. So if you want to switch it, then you have to find the opportunities, or you can say, I can say, you have to find the problem statements which can be answered using the available data in your company. So first you acquire some of the skills of this data, which I mentioned over here in data analyst role, data scientist role. And then you go back after learning skills, you go back and apply those skills on the data available in your company. So in this way, you are actually building some sort of experience in this field as well. And then you can showcase this experience to any other company where you can apply for a data scientist role or maybe data analyst role. So it will be a positive impact that you did some stuff in your company out of the box by learning an additional skill.
Okay, great.
So
Thank you for answering that. Yeah, let me give you my background. I am basically uh in a software field. I am a software engineer. I am working
right.
from in a software from 10 years now. Yeah.
So if you can
Why I
name
asked this
one of the
question?
particular software, I can tell you right away that what is the opportunity for you. So you are working in which software?
You want the name of the software of?
Yeah, maybe the name, or you can tell what the software do.
Basically, what my company do is like more like a project-based solution. What you I mean, not work on the products. Yeah, so it's more like a service industry type of thing. Uh, and why I asked this question, like, if I am planning to create any tool for a particular industry in a data science, using a data science concept, that's why I was asking that what industry I should target for next 5 years.
I think you should target fintech. That I answered that if you
Okay,
want to target
great.
next industry, then that's fintech. But if you want to integrate in your daily routine, then you have to look and go back to the services of the softwares you are providing. Then if I say, of course, the services you are providing, there will be some sort of data generated by your software at the back end. You just need to go, that data can be in a clicks data, any user journey data using those clicks, clicking on the button, any UX UI related data. So you can have a look at this data and see that if there's any user journey problem. So of course the data of clicks using the buttons will be available at the back end. So you just need to find the data points from that particular software which you are building. So that's all I can say. Of course, there's a
Great.
lot of
Thank you
discussion
very much.
in a particular thing, but I hope it's answered for this particular platform. So, okay, we have question
Yeah.
from Akib Javed, Shehbaz, Redmi 5, although it's a phone. So just quick one, guys. We are over the webinar as well.
Sir, I'm in first year student of computer science, so I just want to know that is our college degree is necessary for that particular field, because I think I have
Now,
only increase our professional skills. So
no,
main question is that.
in my personal opinion, many people are doing master's degree in data science and analytics. So I haven't done any master's degree in data science. In this particular field, all that matters is your skills and how you are able to solve the problem. So in this digital era, um, all the knowledge is already available virtually on the websites and on the Google as a free as well. So will not totally recommend you to do this particular masters first and then jump into this field, because the masters costs, there's a cost involved in the master doing the master as well after doing the 4-year degree. And so before doing such a big step, first you need to learn them by yourself, by based on these courses offered by us or maybe available on the internet. Try to know this field, try to do some internship in a similar role, maybe as an analyst role, so that you know that how the industry works. Then you can decide that if you want a higher education or maybe master's degree in data science or not. But personally, as a 10 years professional, I don't have a master's degree or a PhD degree in this particular field. I'm learning those skills, and and I'm learning those skills and applying them on the projects I'm being assigned in my company. So yes, it's not necessary to have a master's or a PhD degree in data science. And you might have known Elon Musk. So what Elon Musk says that if you are a college graduate and you know how to train a neural network, then I'm gonna hire you. So if Elon Musk is saying that there's no there, even the Google is preferring the college graduates who know how to do the Python programming. So even the bachelor degree is actually getting obsolete in next maybe 10 to 20 years. So it's not necessary. Yes, if you want to go in the academia, if you want to be into some research based role, yes, then masters or PhD is required. So it all depends on you if you want to work in industry, or you if you want to drive your career towards academia. Maybe you want to be a teacher to in a particular college, or maybe a research assistant, then yes, you have to do a masters.
Sir, Akib Javed here. Sir, I want a suggestion. Uh, I have basic knowledge of machine learning, but I want to focus on two things like deep learning or ETL. What do you suggest I will do first? I will do deep learning first or ETL first?
Well, if you want to go in the industry, then I will suggest you should learn ETL first, because in the industry, the data is being extracted from the ingestion platforms, and for that, the SQL is used. And even as a start, you can also be a data engineer as well. So the ETL is primarily done by the data engineers. So I'll suggest that first learn SQL, which is primarily involved in the ETL. Then you can go towards, after that you can go towards deep learning. So SQL will really help you in getting a job quickly. Deep learning can also help you, but most of the industries require SQL skill as well. Deep learning is a good to have skills, unless you are going in a particular startup where they are primarily doing deep learning like computer vision, natural language processing, and there's not much SQL is involved.
Okay, sir.
All right, so I have another question from Mi Jing Joy. He's saying that I am a math student focusing on software development. I think that I have sufficient mathematics knowledge, but I have no experience in data science. I want to focus my career in software development, but I would love to learn data science at the side and enhance my knowledge and resume. Do you have any suggestions way I can start with? Yes, Mijan, I have a suggestion for you, as you are good in software engineering and mathematics. So you can just go to a website. Let me tell you a website over here. This website is called Kaggle. So you can just go to the Kaggle. This is a very famous website these days. On the Kaggle, you should create your account and you should go to the compete section. Over here, you can see there are some competitions related to data science, and there are many open source data sets available for a data science. So what you can do as a sideline, you can learn from any course, a course offered by us in English, or a course offered on Coursera or maybe DataCamp, the open source platforms available. Then after learning some skills, you can apply those skills in these competitions available over here. So you can see as a sidekick, there are prizes as well. And as a software developer, you can also learn that how everyone is programming their mathematical models over here. So if I click on this particular competition, you can go to the notebooks and you can study the notebooks of other people. So right now over here, you can see that there's a notebook on PyTorch LSTM. There's a notebook on faster inference by XGBoost with Treelight. So you can just read their codes and see that how the mathematical models are being applied. All the documentation is being provided by the owner of this notebook. So it's a really good learning website, and also an practical applying website. So if you want to do it in sideline, you just keep on doing, and you just pick out any data set from this Kaggle website and start doing things. So you can learn from other people as well, and you can try it yourself as well. So I hope your question is being answered.
Yes, thank you very much.
All right. So I think we are already 15 minutes past our deadline, but it's a great thing that I received lots of question and interest from the audience. So I think I will just conclude the webinar over here. And thank you everyone. If you still have any questions, you can send it to the marketing team on the Facebook page, and the marketing team can forward me your messages, or you can just get connected with me on the LinkedIn. So on the LinkedIn, you can find me over here, or I can share my LinkedIn profile link as well. So you can connect with me on LinkedIn. So this is my profile and I can send it. So if you have any further questions, I'm always open here to guide you all and help you all.
Yes, thank you so much, Mr. Zubair. We had a great time on this webinar with you.
Welcome.
And to
I
all
hope.
the attendees,
Yeah.
To all the attendees, we have mentioned an email in the chat section. You guys can email us for the recording or any of your queries regarding our trainings at info@diceanalytics.pk. Thank you.
Thank you, sir.
Thank you, everyone. Have a nice day or evening or maybe night. Thank you for joining, and I hope you guys have learned something from this webinar today. So keep in touch. If you want to connect with me LinkedIn for any further questions, I'm always open to it. Thank you, everyone. Yes, Michang, I have shared the link on the chat. So I'm sharing the link again on the chat. Here's my LinkedIn profile. Thank you, everyone. Goodbye. And for my Pakistani guys, Allah Hafiz.